We have been hurt far too many times by solid-state battery rumors. For over a decade, we've been promised a miracle cell that charges in seconds and never degrades, only for those promises to vanish like a mirage. For tech enthusiasts, especially those of us who have seen countless revolutions fail to leave the lab, skepticism isn't just natural, it's earned. But today, a pragmatic giant has entered the arena. Geely, the powerhouse behind Volvo and Zeekr, has officially confirmed that its self-developed all-solid-state battery is entering vehicle validation this year, boasting a massive 400 kg energy density. This isn't a startup dream like Donut Lab and its physics-defying claims. This is an industrial response from a global manufacturing empire. So is Geely finally turning the solid-state battery dream into a reality, or is this just another heartbreak? Let's cut through the hype and look at the cold, hard facts. In the world of batteries, energy density is the single most important factor. Most electric vehicles on the road today, including long-range Tesla models, use NMC batteries, nickel manganese cobalt, with peak energy densities of around 250 to 260 watt-hours per kilogram. If you drive a vehicle that uses an LFP battery, such as the standard range Model 3, the number is even lower, roughly 160 to 190 watt-hours per kilogram. Reaching 400 watt-hours per kilogram is not just a minor upgrade, it represents a performance increase of up to 60%. For drivers, this means a car that currently goes 300 miles on a single charge could suddenly travel 500 or even 700 miles without adding a single extra pound of weight. This is the magic number that allows electric vehicles to decisively outperform diesel or gasoline cars in every aspect. So what makes Geely's solid-state battery so special? Geely is not only China's largest automaker, it also owns Volvo, Lotus, and forward-thinking brands such as Zeekr and Polestar. Its reputation is built on a solid engineering foundation, so when Geely makes a product claim, it is almost certainly true. The company plans to sell 6.5 million vehicles over the next few years and expects to deploy 100,000 autonomous robo-taxis. When Geely announced its solid-state battery testing, there was little reason for doubt. The company has a global network of R&D centers and the manufacturing capability to produce millions of vehicles every year. As you know, China has vast material resources, allowing it to achieve major advances in battery technology faster than most other regions. Since the mid-2010s, Geely has been building its own battery ecosystem. A robust LFP design that reaches about 192 watt-hours per kilogram, among the highest in the industry. This battery is nearly indestructible and charges faster than most others in its class. However, Geely also understands the limitations of LFP. It can never be the holy grail, because its energy density is almost impossible to push beyond 200 watt-hours per kilogram. That's why Geely has been researching solid-state batteries for about 10 years, focusing on cell chemistry, solid electrolytes, and integration methods. The company has a dedicated research division and a joint laboratory in China. Recently, Geely confirmed a major development milestone for its in-house solid-state battery. Unlike the rumors or hype surrounding many other solid-state battery claims, Geely's battery is already at the vehicle-level validation stage rather than confined to laboratory research. In other words, its solid-state battery exists in the real world. Geely has confirmed that it will achieve a complete battery pack and begin vehicle installation validation in 2026. The company is pursuing two different approaches: sulfide-based electrolytes, which offer extremely fast ion transport for high performance, and oxide-based electrolytes, which deliver the legendary safety standards expected by Volvo customers. By reaching an energy density of 400 kg, Geely is positioning itself as the first traditional automaker to move beyond the liquid electrolyte era. When Geely says it is testing these batteries in actual cars, it means the company has solved the solid-solid interface problem, the biggest obstacle in battery science where layers tend to crack under pressure. However, the fact that Geely's solid-state battery exists in the real world does not necessarily mean you'll be able to walk into a showroom and order a solid-state EV this year. That's because the first vehicles equipped with this technology will be test and validation cars, and there's also the reality that Geely does not sell vehicles in the United States, although buyers in Europe and Australia can purchase its cars. But as we mentioned earlier, Geely is a massive company. In addition to Volvo, it owns Lotus, Zeekr, and Lincoln Company, so it's not far-fetched to imagine that any of these brands could one day offer solid-state batteries in their electric vehicles and that we could actually buy them. However, in contrast to Geely's solid-state battery, another solid-state battery claiming the same 400 kg energy density has stirred controversy over the past month. Yes, we're talking about none other than the Donut Lab all-solid-state battery. According to Donut Lab, they confidently claim this is the world's first solid-state battery that can be mass-produced and has a lifespan of more than 100 years. While Geely only states that its solid-state battery reaches 400 watt-hours per kilogram, Donut Lab, says its battery can fully charge in just 5 minutes. More strikingly, it is claimed to be the first solid-state battery that can charge smoothly from 0 to 100% without slowing down after 80%, while also maintaining 99% performance from 30 degrees Celsius to 100 degrees Celsius. To be honest, 100,000 charge cycles is absolutely insane. A typical EV battery lasts around 1,500 to 3,000 charge/discharge cycles, which is enough for roughly 15 to 20 years of use. In theory, a battery with a 100,000 cycle lifespan could operate for well over a century. Industry experts, including the chairman of China's battery giant Svolt, have openly called these specifications contradictory and have even labeled the claims a scam. How can a battery have the highest energy density in the world, the fastest charging speed ever recorded, and a lifespan longer than human civilization itself, while also being cheaper than standard lithium-ion batteries? Geely's path, by contrast, is very clear. The company has its Ningbo testing facilities, thousands of patented safety systems, and a supply chain that has already produced millions of vehicles. When Geely announces a 400 Wh/kg battery, it is backed by China's national research programs and a decade of continuous refinement built on its short-blade technology. On the other hand, Donut Lab remains something of an enigma. Some investigations suggest that the company's solid-state batteries actually rely on technology from Nordic Nano, a partner company, but Donut Lab has not acknowledged this. At the same time, Donut Lab has yet to provide independent third-party certification for these breakthrough performance figures. Their batteries are reportedly set to be used in Verge motorcycles, but the automotive industry is still waiting to see whether these vehicles can truly achieve an energy density of 400 watt-hours per kilogram under real-world production conditions, or if this is merely a marketing gimmick. Whether it is Geely's meticulous manufacturing engineering or Donut Lab's bold claims, one thing is certain: the solid-state battery boom is underway. In Europe, politicians are debating a ban on gasoline-powered vehicles starting in 2035. But with Geely's 400 watt-hours per kilogram batteries scheduled for on-road testing in 2026, those bans could become irrelevant. Why would anyone buy a vibrating, polluting, fuel-hungry internal combustion vehicle when they could own a solid-state electric vehicle that can travel more than 600 miles on a single charge-recharge as quickly as grabbing a cup of coffee and is nearly fireproof thanks to the absence of flammable liquids? Clearly, solid-state batteries are emerging as the true holy grail that many companies are striving to attain. Geely is far from the only player investing in this technology. Dozens of major names, including Dongfeng, SAIC, Chery, Mercedes-Benz, Stellantis, and BMW, are partnering with battery developers to unlock the secret and bring this breakthrough technology to the mass market. The United States is taking a different approach. Rather than having automakers build batteries entirely on their own, specialized American technology companies are partnering with major auto brands to put their technologies on the road by 2026. Factorial Energy, based in Massachusetts, is a notable example. The company is working with Stellantis, the parent company of Jeep and Dodge, as well as Mercedes-Benz, to equip a test fleet with its solid-state batteries later this year. This test fleet represents the final step before these batteries can be sold to the public. Another major U.S. company is QuantumScape. After years of development, it plans to launch its Eagle Line pilot manufacturing facility next February. This production line is designed to manufacture solid-state batteries for the Volkswagen Group. According to the company, full-scale mass production is still 1 to 2 years away. But the start of automated production in 2026 is a strong signal that the technology is nearly ready for real-world deployment. In other news, in the early days of 2026, Tesla Cybercab prototypes were officially transported to the icy terrain of Alaska to undergo some of the most extreme winter testing imaginable. This marks a critical validation phase before the steering wheel-free robotaxi enters mass production in April 2026. In Alaska, Tesla engineers are focusing on pushing the Tesla Vision system to its limits, the heart of the vehicle, which relies entirely on cameras for navigation. In conditions of heavy snowfall, dense fog, and roads covered in black ice that completely obscure lane markings, the Cybercab's artificial intelligence must prove its ability to localize itself and maintain absolute safety without any human intervention. In particular, to address the long-standing weakness of cameras in winter conditions, Tesla has equipped these test vehicles with a dedicated rear camera washer system, ensuring clear visibility despite dirt and road salt buildup. Beyond autonomous driving, Alaska also serves as an ideal laboratory for testing battery performance and wireless charging technology. In sub-zero temperatures, inductive power transfer efficiency can be affected by thick layers of ice accumulating beneath the vehicle, and Tesla must ensure that charging efficiency remains above the promised 90%. These prototypes are also fitted with specialized winter tires to fine-tune traction control algorithms, helping prevent slipping on icy surfaces. Winter testing in Alaska demonstrates that Tesla is preparing to deploy the Cybercab across a wide range of climates in the United States. Low temperatures, snow ice, and reduced traction represent some of the harshest conditions for autonomous driving systems, making Alaska a logical testing ground for a vehicle designed to operate without a driver. In a post on X, Musk reiterated that Cybercab production is expected to begin in April, reaffirming his guidance on the vehicle's production timeline. Elon Musk also warned that Cybercab production will ramp up slowly, reflecting the challenges of launching an entirely new vehicle platform. In a recent comment, Musk noted that early-stage manufacturing typically follows an S-curve, with initial output constrained by the number of new components and processes involved. According to Tesla's CEO, both the Cybercab and Optimus fall into this category because almost everything is new. As a result, the initial production pace is expected to be very cautious before accelerating rapidly once manufacturing processes are fully refined. At the World Economic Forum in Davos this week in January 2026, Elon Musk once again sent shockwaves through the tech world by declaring that the self-driving problem has essentially been solved. Going beyond theoretical claims, the billionaire laid out an ambitious timeline. Tesla expects to receive approval for its full self-driving supervised system in both Europe and China as early as next month. This is widely seen as a historic inflection point, shifting the focus from development to a phase of explosive global commercial deployment, especially as Tesla's fully driverless robotaxi service has just officially launched in Austin. In the European market, Musk's February target is grounded in reality, thanks to a roadmap already agreed upon with the Dutch Vehicle Authority. Tesla is pursuing a smart strategy by seeking a national exemption in the Netherlands rather than waiting for the European Union's notoriously slow legislative process. If approval is granted by the RDW, a potential domino effect could follow, with other EU member states choosing to recognize the exemption on an individual basis. This would allow millions of Tesla owners across Europe to officially experience FSD for the first time. This confidence is further reinforced by Tesla's extensive FSD ride-along program across Germany, France, and Denmark, aimed at convincing regulators of the system's safety. In China, however, the picture is more complex. While Musk has expressed optimism and Tesla has reached key data security agreements with Baidu, Chinese authorities remain cautious. Sources within the Chinese government suggest that the next month timeline is not realistic, as safety compliance reviews and mapping evaluations are still ongoing, delaying the rollout of FSD v13 on vehicles equipped with AI-4 hardware. Despite procedural hurdles, Musk's confidence in 2026 carries a very different weight compared to previous years. With the arrival of FSD v14 and the vastly superior processing power of the upcoming AI-5 chip, Tesla is steadily turning long-standing promises into reality. The autonomous fleet already operating in real-world conditions in the United States is the strongest proof yet for international regulators that self-driving technology is ready for large-scale deployment worldwide. 2026 could be a breakout year for Tesla's AI efforts. Elon Musk, together with Tesla's supply chain partners in South Korea, has outlined an ambitious vision for AI-5, the next-generation chip widely regarded as the key to unlocking Tesla's future. Far more than a simple upgrade, AI-5 represents a shift from a conventional automotive processor to a compact supercomputer integrated directly into the vehicle. The biggest breakthrough of AI-5 lies in its staggering compute density. According to Elon Musk, a single AI-5 system-on-chip delivers performance comparable to an NVIDIA H100 GPU, a $30,000 data center monster that consumes up to 700 watts of power. When two AI-5 chips are paired together, their combined performance could even rival NVIDIA's latest Blackwell B100 B200 lineup. Imagine this: Tesla has effectively compressed the power of a massive data center server into a compact device tucked behind the glove box, running off the car's low-voltage battery and at a fraction of the production cost. This means that every future Tesla vehicle could possess artificial intelligence on par with the most powerful supercomputers in the world today. Why does Tesla need such enormous computing power? The answer lies in FSD unsupervised and the humanoid robot Optimus. While the current AI-4 chip is already running FSD v14, impressively, Elon Musk has acknowledged that achieving absolute safety and handling complex traffic scenarios in a truly human-like manner without any driver intervention requires an exponential increase in compute. AI-5 is the solution that makes this vision achievable. It provides ample computational headroom to run deeper, faster neural networks, enabling the vehicle to react instantly to its surroundings. On the supply side, Samsung's factory in Taylor, Texas is set to begin equipment testing next March in preparation for mass production of AI-5 in the second half of 2026. Although AI-4 will remain the primary platform for the Cybercab launching this year, AI-5 is expected to gradually take over as the main architecture starting in 2027. Notably, as the design of AI-5 nears completion, Tesla is shifting its focus toward Dojo 3. If AI-5 is the brain that enables vehicles to reason and act on the streets, then Dojo is the massive server system used to train those brains. The combination of AI-5 in the vehicle and Dojo in the data center creates a closed end-to-end ecosystem in which Tesla maintains full control over everything from hardware to software. Tesla is transforming from a pure automaker into a comprehensive AI and autonomous robotics technology empire. This is no longer just a year of plans on paper, it is the moment when Elon Musk's most ambitious projects begin to bear fruit. At the center of attention is the start of mass production of the Cybercab at Giga Texas, paving the way for a truly driverless robotaxi network. This milestone, combined with the maturation of next-generation full self-driving technology, is expected to trigger a fundamental shift in Tesla's business model from selling hardware to delivering ultra-high-margin software services. At the same time, Tesla plans to fill the mass market segment with a new generation of affordable electric vehicles, helping realize its mission of making sustainable energy accessible on a global scale. Manufacturing efficiency is also set to reach new heights thanks to the continued refinement of the 4680 battery technology and the Giga casting process, optimizing costs and reinforcing Tesla's competitive edge amid intensifying rivalry. Beyond Vehicles 2026 is also expected to mark tangible progress for the humanoid robot Optimus as it begins to play a deeper role in Tesla's internal production lines, demonstrating the company's long-term vision of a fully automated future. In short, with the convergence of multiple breakthrough initiatives from robotaxis and affordable EVs to industrial AI, 2026 could be the year Tesla reasserts its identity, even after having lost the title of the world's #1 EV manufacturer to BYD. What do you think about solid-state battery technology, the Tesla Cybercab, and the AI-5 chip? Will Elon Musk succeed with these major projects this year? Drop your comment below. Thanks for watching.